This picture shows the mapping of a test to get into the details of AWS, a large company with more than 35,000 people working in here, with various functions. And on LinkedIn you can see what they do. Here you get it in detail. So you have your total number of 35,000 people plus, and you see in the various categories what they do. We later call this function with all the details you need to get your assessment on those people. And when combined with the ONET where the standard occupation code has been born, then you can combine and look for those individual functions like here on engineering. Put that into a spreadsheet here just for the function, the code and occupation in it. With this we are able to combine those codes with the codes we have already in our system with over 202,000 details on 1,028 occupations and their 2025 work activities related to more than 15,000 tasks. With such a generic database one can carving out by just using the occupations and the numbers thereof, we have a pretty good assessment of the related potential activities. Enriched with other information from the income statement and the transactional data for the period in question, we are getting into a detailed business model very quickly. We can now start and get into the details on those 124 occupations. When combined with our codes and their occupation and their related activities, the purpose is to look for the SWB on the median basis, all coming from the U.S. Bureau of Labor Statistics. We then have the enhanced assessment cost of that organization across everything they do. Then we are left with just two other unknowns, which is energy and other costs. So our workplace costs typically have SWB and you can read it here, but there's certainly a lot of energy and other costs involved. We don't know. But if you are at Amazon AWS, you would know that, and I'm just digging into the details getting the SWB on what they actually do, and then you have to make an assessment on the energy part and the other costs. So now, after some learning, we make our own dedicated map out of this function, and we also do have the costs and the income because of revenue and income. We know the two major numbers. And we now can use the details we have learned in here and take the general work activities and make it all from here. We are now living on 110 occupations and their related general work activities. And we have a map here doing all the details, so we know what have on that basis a proper business model was details on those activities, and we take here 20 products representing 20 different types of services AWS is offering. We combine that on here, that is rapid business modeling's normal bread and butter business. And we get here 200 segments showing this as a customer whale curve, assuming that there are 200 segments for the maybe 1 million actual customers. But we can't know that. So the purpose of the exercise is just to get closer into the assessment on that particular example. As close as possible to a certain reality. On the next step we show again on the two-step profit increase. This shows the ideal customer profitability based upon almost none dependency of any customer. Once you have that model in your hand, and the purpose is just to show that that is possible. And we turn this whole flow builder function you see into a function which is having that name, and when you run it, it will get exactly the same result. But without all the details of the flow builder map. That is the general way to go forward, and here we just play with the whale curve showing the various function, and here we have a bar chart showing the activities so you can hover over them. They're active when you click on it, and in the same for the Pareto. We come up with the result we picked up before, and we now go into the details of the activity for that particular case. I just wanted to show you how that could look like, also for pretty large company. Thank you for watching.